Hello everyone and a very good day. In this video we are going to present about our project topic, which is Xerox machine is a photocopying machine. So we implement this project in a group of two. So my name is Chen and my another group mate is Simon. So this is our project statement. Our project objective is to design a Xerox machine that require end user to input the password to activate the component, such as comparator, asynchronous counter, and decoder multiplexer or demultiplexer, and so on. So once the component has been activated, the machine will allow user to select the properties of printing, such as paper size, color, or printer mode. If no properties is selected, the machine will use the default properties. Lastly, the machine will require user to enter the amount of copies. Therefore, the machine will count the number of copies that has been copied. So the machine will stop once the required number of copies has reached. So basically, this is our project objective. So this is our proposed solution to the system. As you can see, this diagram represents the system block diagram of our Xerox machine design. As according to the project requirement, we must implement a password operator to verify if the user has the authority to use the Xerox machine or not. So we construct this operator by using 4 decoder. So we are using 4 to 16-bit decoder because we want a strong security. So this one is for the security purpose. Once the user has successfully input the password, the AND gate of this 4 decoder will push a signal to the multiplexer. This multiplexer is work as a data selector, meaning that the user will be allowed to select the printer properties. So, for example, the user can select the printer mode, the paper size, or the color. If the user doesn't choose any printer properties, the Xerox machine will use the default properties as well. So the multiplexer will finally push a signal to the clock disabler. So this one is the clock generator. The clock generator will also push a signal to the clock disabler every time the system makes a printing. After that, the user will be required to input the amount of the copies that they want. After the user input the amount of the copies, the 4-bit switches will push a signal to the comparator. So this comparator is work as a distinction to compare whether the required copies has met with the printed copies. So how does this work? It depends on the asynchronous counter. So this asynchronous counter will count every time the Xerox machine make a printing until the required copy has met with the printed copies. And then the machine will stop printing. So after that, the user will be required to reset the asynchronous counter to the default state, meaning that the user must set the preset to 0 and the clear to 1 to reset its counter to the default state. So the system will be able to reuse again. Alright, so that's how the Xerox machine works. So this is the components that we use to construct our circuit. So firstly, we are using 4-bit counter to create the asynchronous counter. So how did we create this counter? Is using JK flip-flop that we learned from the chapter 7 and chapter 8. So when every time the machine make a copy, the JK flip-flop will make the different state to represent the different count. So until the maximum of the count has reached or the number of the printed has met, and then the system will stop printing. So that's how the JK flip-flop work as well. And then we are using 4-bit comparator to compare whether the required number of the copies has met with the printed copies. Also, we are using 4 to 16-bit decoder to construct our password operator. And then we are using multiplexer and demultiplexer to construct our properties operator. So this input switches is used for the user to input the number of the copies that they want to copy. So this clock disabler will work as a signal redirect will work as a signal redirector to push this signal to the machine to make a copy. So that's how the clock disabler work. Also, this clock disabler will push a signal to the counter to make it to next step every time the system make a printing. So lastly is the 7-segment display. This display is to display the number of the copies that has made. So that's it for the circuit components. Alright, so this is our circuit design. Basically, we divide our circuit into few parts. So very simple. Firstly, we have password. This is password operator. So we are using 4 decoder, 4 to 16-bit decoder. So we have 4 decoder to construct this operator. So this one is the AND gate. Once every bit is correct, and then this AND gate will push a signal to our multiplexer. So this one is our properties operator. So the user will be allowed to choose the printer properties that they want, or maybe using default properties as well. And then this one is the operation. This one is network printer, and this one is local printer. If the user choose the one as a network printer, and then the signal will coming through this AND gate. If the user using local printer, the signal will push and through this AND gate and activate this part of the circuit. So that's it, how our circuit works. Finally, this one is a task contribution between me and my group mate Simon Chong. Simon Chong, as a group leader, he is specialized in the implementation of multiplexer and demultiplexer. This one is for the part of the system properties. So he's also specialized in the implementation of 16-bit decoder. This one is the part of the password operator. So he's also specialized in the circuit combination. Because we divide the task equally, so after we have done our own part, and then we combine the circuit together. So he's also specialized in project report and circuit demonstration. For the circuit demonstration, he will be responsible to present this demonstration later on. After my slide presentation has done, I will leave it to him later on. So for me, I'm responsible in the implementation of asynchronous counter by using JK flip-flop. Also, I'm specialized in the system block diagram drawing, 4-bit comparator, and clock disabler. Also, I also involved with the presentation of slide. And lastly is the video editing. So that's all about the task contribution. And now I will leave it my presentation to my group mate Simon. So thank you for listening and have a good day.
Hello everyone, I'm Simon, and Chen Junxiang is my group member. I'm going to demo our digital logic project, which is for step machine using DIT simulation circuit. Okay, if you want to use the machine, the first thing you have to do is you have to push the button to on it, to switch on the machine. This is the main switch here, and if you see the LED light out, means the machine is running now. So the second thing, you have to key in the password. The passwords are given here, 1013 and 4-bit for each digit of the password. Means 1, you want to push 1, you can refer to the number here. For example, the first digit is 6, so 2 plus 4 is 6, 2 plus 4 is 6, and close is 1, so the first digit is 6. Just an example, okay, copy to 1 here. Okay, the second digit is 0, the third one is 1, and the fourth one is 3. So let's set it 0, so we don't push any button here. Default is 0. Okay, the third one is 1, push 1. So the last digit is 3, so 2 plus 1 equal to 3. You see the output is 3 here. Okay, maybe you will ask me, you wonder why did I use 4 to 16 decoder instead of 1 to 4 decoder? You try to imagine if in the future I want to replace this password. For example, I want to put 9696 here. Okay, how did I get 969, the digit 9, from a 1 to 4 decoder? Due to the 1 to 4 decoder, the maximum number is 3. Okay, so means I have to replace every of the each decoder here. I have to replace every decoder, so I think it's such wasting time and energy. So why not I just use a 4 to 16 decoder, so I can change my password anytime, so without changing any hardware here. I can save my time and energy as well. Okay, same goes to here. Actually, we don't need to connect every wire to here. We just need to connect the output that we want, just connect to here. But I just want to show you, for decoder, when you push the button here, there is only one input at once. Means, for example, here I push 1, so the output is 1, and this is the only wire that triggered. Means there's only this one, and the rest are 0, 0, 0, 0, 0. So for example, I want to 4 plus 1 equal to 5. Okay, so the 0, 1, 2, 3, 4, 5. So the fifth output, okay, this is the sixth one actually, because I start from 0, so the sixth output will be triggered and the rest are still 0. I just want to show you this, so I connect every wire to the array LED. Okay, 1, 0. Okay, change back to 1. Okay, as you can see, the LED here doesn't work because our password is wrong. Okay, change to 1. So the password is correct now. You can see the hello is work. It's keep blinking here, so means your password is correct. You can move to the next step. Okay, this is for you to choose the properties here. Okay, for example, I want to print a color paper. I push the button here to 1, means 1. The output is equal to 2. Because this is a multiplexer, means the first is 1, the second one is 2. So the output is 2 here. Okay, so this is the LED array here. I just want to show you how does it work here. Means 2 is the second input here, so this will be the second output here. Okay, because with this one, if I want to print A3, for example, A3, you have to push the button 1, 0. So 1, this 0. So if you push 1, 0, means this 1, 2, 4. So the output is 4, and the third input will be this is the multiplexer. When it goes to the demultiplexer here, it will show you the same thing. So the input is third, the output is third as well. Okay. Next is the zoom ratio. For example, I want to zoom 150 here, 150%. I need to push. So this is the third wire. I don't show you here. So you have to count 1, 2, 4, 8. So this is the third one, 150% is 1, 0. Same thing. If you want to zoom 200%, just push 1, 1. So 1, 2, 4, 8. The output is 8. The fourth input and the fourth output will be triggered. Okay. So this is let you to choose the local printer or network printer. 0 means local printer. This is a default. This why it shows 1 here, because this default is local printer. If local printer, what does it mean? Okay, what does it mean here? Local printer is this one. This is local printer at the right side. Okay, if you want to use network printer, you push the button to 1, so the output is 2, the second input will be triggered. Okay, so it means if you choose network printer, it goes to here, left side, where is the network printer here. Okay. Okay, so for example, I choose a local printer. Local printer is 1, first one. So as you can see, the LED is light up here. Okay, let's go to the operation here. How does it work? Okay, let me explain one by one. Okay, if you can see the difference here, I'm not using like the password input. You have to key in the 1 digit one by one. You have to press the 1 and 0. So now I'm replacing by this one. The same thing, but just a different hardware. So you can control the 4-bit number in one hardware. Okay. For example, I want to print, you can see the number here. For example, I want to print 6 copies. So press this one, 4, the third one, the second one is 2, so input 6. Okay. This is the counter, asynchronous counter. The preset is 1, means I was always on this one, and this clear button if you want to clear the number that you have entered. Okay, so now if I want to on it, so I put 6 here, I just press the clear button here. Okay, it start counting up here. As you can see, there's a printer start counting up. Okay, it stopped. Why? Because the printed number of the copies is equal to the required number that you want to print. Okay, so this is a clock disabler. When the printed number is equal to the required number that you want to print, the number of copies are same, the clock disabler, this AND gate will send here, will send a 0 message here. Send a 0 message to the clock in JK flip-flop here. Even though the clock is still keep pushing, but due to this is a 0 condition here, and this AND gate, if this one is 1 and this is 0, so the output will be 0. You can see the LED light is stop lighting here. Okay, if you want to clear, to reset, just press it, and you want to set it as, for example, 4 copies. Start it again, press it. Okay, this one is keep counting up. Okay, stop. Okay, how does it work? And you can see there is a comparator here. For example, okay, this is, for example, my required copies is 1. For example, only explain 1 bit here is 1, and the number of copy currently is 0, so they are different. When it comes to here, so due to this 0 different, so this comparator, the output is 0. What is 0? It convert to 1. Means the required copies is not equal to the printed number. Means there are still some set to copy. So it's equal to 1. Send it to here, 1 and 1. So condition is true. You send it to here, the clock will counting up 1. Okay. Until it is the printed number and the required copies are same, so the output equal to 1. Imagine each of the bit here is same. For example, 1 0 1 1. So okay, let's say this one 0 0 1 0. Okay, so this one is received from the JK flip-flop is 0 0 1 0. So means the condition they have the same values, so means this is all equal to 1. When it's all equal to 1, it's go through the AND gate here, it will equal to 1 here. But when equal to the inverter here, it will become 0. Means the printed number is same as the required number. Means that there's copy completely. There's finished. So when it's 0, the clock disabler will stop the clock to counting up. Okay. So same goes to the network printer here. Just I change a bit, which is you can just select the number here instead of using to choose every number for each bit. So you can choose, for example, you want 5. Okay, I forget. Before you choose to here, you have to change this one to 1. If you choose 1 here, means it's 2. The output is 2 here, and it will go to the network printer. Go to left side. So this one you can choose any number that you want to copy here. For example, I want to copy 7. Okay. Preset I have to set to 1. Okay. Clear button if I want to 7 here. Okay. I push the clear button to start the copy. Press. So as you can see, it will keep counting up here. The LED keep lighting. Okay, 7, 7, same value, it will stop. Okay, so this is how our circuit works, and we implement some advanced function here, which you can choose either local printer or network printer, and the rest are the properties here. And the password, I have to mention something here. Due to the password, you have to key in 4 digit and 4 bit for each digit. So it means you have to input 4, 4, 4, 4, 4. So it means 4 times 4 is 16 bit. You have to input 16 bits of password here, which is 65,536 combinations. So it's quite. It has a strong security in this machine. So I think that is all from me. We are from the group, and this is my group member. Okay, thank you.